So up until recently, we never really had stories like this. But in just the last 2 years, there's now been quite a few reports of basically random space trash being discovered in some of the more bizarre locations. Here's one from a Kenyan village, and here's one from Australia explored by Dr. Brett Tucker on YouTube. And that's of course a sign of something that has now become a major issue. Not space debris landing on someone, but actually space debris right there in outer space, mostly in the low Earth orbit, that has now become such a major problem that one of the recent studies, the study you can find in the description by Sarah Thiel and the team you see right here, suggests that we now have reached a critical juncture. The scientists behind this study actually refer to this as a house of cards. We're now extremely close to the famous Kessler syndrome, also known as the Kessler effect, that describes a situation where the density of objects in the orbit becomes so high that they basically start colliding and increase the density of particles as a result of each individual collision, eventually making these orbits completely unusable. And so this region that's crucial for communication, navigation, and global internet may now be in a lot of trouble. And all of this thanks to megaconstellations. And so, hello wonderful person, this is Anton. Today we're going to discuss some of the other issues these megaconstellations seem to be causing us, and basically discuss this new study and the famous Kessler syndrome, an idea that's actually pretty old. It was originally formed back in the 1970s, and it's essentially just a catastrophic chain reaction that can eventually trap humanity on Earth by making orbit too dangerous to use. But the discovery in this research is actually a little bit unnerving. It suggests we don't actually have decades to plan for this, and instead we might only have days, especially if there is one particular event that happens. I'm gonna keep this as a mystery for a few minutes, and we'll discuss this very soon. And all of this is of course because of this very bizarre orbital traffic jam. And this is something that we don't really hear about much, but basically today, here we're talking about early 2026, mostly because of these megaconstellations, such as the Starlink satellites. Pretty much every single day, at least 2 satellites pass very close to each other every 22 seconds. Here we're talking about a distance of less than 1 kilometer. And let that sink in for a moment. Every 22 seconds, basically 3 times per minute, at least 2 satellites approach each other within 1 kilometer. And if we look at only Starlink, which of course makes up an overwhelming majority of active satellites, here these close approaches happen every 11 minutes. But to keep things running smoothly and to basically avoid collisions, satellites obviously have to move constantly. On average, each of these Starlink satellites has to perform 41 maneuvers per year just to avoid running into other objects. And since we're talking about thousands of satellites, that means that there are over 100,000 different maneuvers that have to be executed every single year just to maintain this network. So yeah, talk about complexity. But so far it's been running pretty smooth. Because of the constant observations and perfect maneuvering, so far there have been no major collisions, despite the increased number of satellites. But here I do have to highlight something very obvious. Here we have a total reliance on absolutely flawless maneuvering system. Here we rely on operation without any errors. But as the saying goes, to err is human. So you know, how long before we make a mistake? And speaking of mistakes, a quick side note. You might have heard that a few months back in 2025, one of the Chinese capsules, Shenzhou 20, was indeed struck by a piece of space debris that was completely unanticipated. And this trapped 3 of the taikonauts, or Chinese astronauts, for a week in space. Which essentially illustrates that here we can never really predict when something like this actually happens. And so this classic Kessler syndrome problem is a bit of a slow burn. It may take decades or even centuries, or might happen suddenly and all at once. And that's basically the proposition in this study, that sudden explosion, or sudden increase in particles out of nowhere for some very specific reasons that might happen without anyone being able to control anything. And so here they introduce a metric referred to as crash, collision realization and significant harm. And here this crash clock measures the time it would take for a catastrophic collision to occur if some of these satellite operators suddenly lost the ability to send commands for avoidance maneuvers. So basically if suddenly Starlink goes offline, or maybe SpaceX goes bankrupt and leaves all of these satellites orbiting in space, how long would it take before these collisions start to happen and increase in numbers? And so this is a test of orbital environment and how fragile the systems are when it comes to modern satellites. And the results are quite staggering. So here's what the scientists calculated. For example, in 2018, before the megaconstellations began, this crash clock was approximately 121 days. Basically here, if suddenly we lost complete control of satellites and everyone just fell asleep, it would very likely take 121 days before a single collision occurred, giving us just enough time to recover from a system-wide failure. So essentially 8 years ago, it was quite possible to prevent the Kessler syndrome from becoming uncontrollable. But what about today? Well, as of 2025, specifically June 2025, the crash clock plummeted to just 2.8 days. Okay, let me repeat this again. 2.8 days. We only have less than 3 days to correct anything if the maneuvering system suddenly becomes disconnected. And so this 2.8 day window means that if we lose control of our satellites, a major collision is expected in less than 3 days. And here's the most disturbing part. If operators lose control for even 24 hours, there is still a 30% chance that at least one collision will still occur. And even a single event would generate enough debris to act as a seed for a decade-long process of Kessler syndrome. Basically, each particle is going to collide with something else, destroying another satellite, which then creates more particles, and so on. And so this has now become a major issue, and that's still based on 2025 data. We obviously have more satellites coming out from Amazon and from the Chinese companies, and so pretty soon 2.8 days is going to become just a few hours. But I guess here we still have one question. Why or how would we lose control? Or can we actually lose control of satellite networks? And is this something we should be worried about? And the answer is an obvious yes. And there are some videos about this in the description, but in a nutshell, 2 words. Space weather. Specifically, solar storms. Very powerful solar storms like the one from 2024 pose 2 primary dangers for these satellites. One of them we've already experienced in 2024 as well, with SpaceX losing several satellites all at once. A typical solar storm will usually heat up atmospheres so much that it actually increases the atmospheric drag on satellites and creates positional uncertainty because they now start to orbit in a slightly different way from what was initially expected. And this forces satellites to use more fuel and perform more evasive maneuvers, but in many cases basically makes their orbits super chaotic. And so the 2024 Gannon storm that we've actually recently discussed in one of the videos in the description was strong enough that over half of all satellites in the low Earth orbit had to use a lot of fuel just to reposition back and to avoid orbital changes. But a much more serious problem during these storms is of course a more systematic failure, because here these storms can definitely take out navigational and communication systems and basically completely destroy various networks. Now in 2024 we kind of got lucky, nothing major so far has been destroyed, but if the systems responsible for real-time tracking and control suddenly fail, here the satellites would become completely uncontrollable and would eventually definitely collide. And the problem in this case is that normally we only get like maybe 2 or 3 days to prepare for some of these solar storms. So basically once we see the emissions coming from the sun, there is very little time to prepare. And so if this real-time control is lost, we literally only have 2.8 days before the orbital house of cards completely collapses. And based on some of the previous data and previous experiences, we know that the sun can definitely create a much more powerful storm. And so if there is a major storm in the next decade, in theory, it could completely wipe out our ability to control satellites for much longer than just 3 days, which of course would lead to that Kessler syndrome. And here it doesn't just mean destroying satellites and destroying internet, it literally means destroying access to space. None of the satellites will be functional anymore, and there's going to be no way for humans to travel to space for a very long time, just because the entire orbit is going to be covered in these very tiny particles moving at ridiculously high speeds. And even a single one of these can easily take out an entire spacecraft. And so here we do have a somewhat intriguing but also a little bit of an unnerving study that creates this crash clock, something that measures the immediate risk of system failure and something that basically points at the underlying problem. Huge amount of debris in space and huge amount of particles, and of course these enormous megaconstellations. But the thing is, the classical Kessler syndrome describes the situation where this debris growth sort of outpaces the natural removal processes caused by atmospheric drag. And so in the classical calculations, this process does take decades or even centuries to develop. But these classical calculations did not consider the existence of megaconstellations. Here in the lower orbit, approximately 550 kilometers above the surface, we may be within the threshold where even a single collision would be enough to start all of this and to create catastrophic long-term consequences lasting for centuries. Although obviously megaconstellations are not the only concern, because historically there were at least 2 major issues. First, the so-called anti-satellite missile tests, such as for example the Russia's 2021 test that instantly created thousands of fragments when they wanted to test a new weapon. China did something very similar approximately a decade ago, which ironically might have been one of the pieces that then hit their own space station. But we also have very large unrecoverable rocket stages that may stay in orbit for many decades as well, and slowly fall apart, creating even more debris. And so essentially this is a multi-level problem that at the moment basically has absolutely no solution, even though there have been some changes in terms of policies in the last few years. For example, in the US, the FCC changed some of the rules, now requiring defunct satellites to be disposed within 5 years. This is a dramatic improvement from the previous requirement of 25 years. And so now when satellites are designed, they have to have a way to return to Earth in order to prevent even more space debris. And interestingly, not so long ago, US has finally issued the first ever fine for space debris violation. This was a fine to Dish Network for failing to properly deorbit their satellite known as EchoStar 7, as they previously agreed to do. And so back in 2023, US government issued a $150,000 fine, making this the first such event. But obviously right now these changes are just not enough. As a matter of fact, if the entire system fails, and if there is a major solar storm, none of this is going to prevent Kessler syndrome from happening. And so the reality is that while these megaconstellations do provide us with a lot of new technological capabilities, they have also created a system that has now become extremely vulnerable to being completely shut down. And specifically because of these very unpredictable powerful events coming from the sun during some of these geomagnetic storms. And so assuming that we want to go back to space and we want to use satellites, here we need to have some kind of a long-term sustainable practice and much better policies that are always enforced in order to manage these orbital environments much better. Because as it is right now, our entire use of satellites unfortunately hangs on this very fragile system involving continuous, uninterrupted and perfect maneuvering of tens of thousands of different satellites that can collide at any moment. And so in this case, we might have to decide if it's actually worth it, and if the benefits of worldwide internet are actually worth the risk of basically losing absolutely everything in space within just a few days. And so a pretty intriguing and somewhat unnerving study, and something we're going to explore in some of the future videos once there are some additional follow-ups. Until then, check out previous videos on this topic in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.